Hello, welcome to HCR Training Course Chapter 3.4. In this chapter, you will learn about advanced commands like vision, pattern, and path. This is final chapter of basic training course and contains important skills to make automation system easier. Let's start with Roadie Simulator. Please click on button to start simulator and go to the programming screen. If you click the commands icon, you can see 4 advanced commands: vision, pattern, script, and path. We will handle script command and its detail functions and grammar at the other course. Before you use vision command, you need to make device setting for vision system. Please click the device setting menu and click the vision system. In this screen, you can add vision devices and also its workspace. To add a new vision system, please click the plus button on the vision list tab. After that, you can modify the name, register the model as you want. Roadie 1.6 is compatible with 5 vision systems. And also you can use other kinds of vision systems in the future. Please choose one of models as you want and go to the next step. There are 2 vision types in this menu. Select embedded when your vision camera is mounted on the robot's arm or flange. Embedded means that camera will move according to the movement of robot arm. On the other hand, you need to select standalone if your camera is fixed and does not move when the robot is moving. After you select the vision type, please type the IP address of your vision system and also type the port number. After that, click the connection test button to find out whether the connection status is good or bad. In the Roadie Simulator, I'm sorry but we cannot add actual or virtual vision system to test the connection status. So, I recommend you to use real HCR for this training step. If the vision system is well connected, click the Save button to save the vision system properties. Now you can add Vision Workspace for this vision system by clicking the plus button on the Vision Workspace tab. You can add other vision systems and also each of your system can have their own Vision Workspace. Each vision space contains its own calibrated area and vision model data. Let's click plus button to add a new vision workspace. In the vision coordinates calibration screen, you need to let the robot know how to convert the vision position data to the robot position data. Type the name of this vision workspace and click the set point button in the vision scan coordinates tab. Vision scan coordinates means the position of robot when the camera take a picture to figure out where the model is. If your vision system is embedded type, you need to move robot and also camera to the best position to take a picture. If your vision system is standalone type, you need to move your robot not to disturb taking picture and finding a best model. To sum up, this position is standby position for taking a picture and getting the vision data. After you make a standby position, you need to make other 3 positions to calibrate the robot and vision position data. Please click P1 or P2 or P3 icon or the tap area of each position like me. You need a calibration board for this step. Please click Set Point button to move your TCP to the specific point on the calibration board. In this video, let me guess that there is a vision calibration board on the base plate and the Z position data is 0. After you find out the robot position data, you need to find out the position data of the specific position from your vision system. Please type the data from your vision system in the vision coordinates field. You may find the pixel data from your vision system. Please repeat the same calibration sequence for other 2 points. After you finish the calibration sequence for 3 points, you can see a pop-up screen for vision test. If you've done this calibration sequence well and your vision model is finely defined, you can see a vision and robot position data by clicking the test button on the screen. If there is no error with this test, only one step is left to finish this vision setting. You can find a rotation angle data in the R field on the Test tab. In many cases, we need to make a rotation offset to grab the target object finally. You can rotate your tool to grab the object according to rotation angle data as you type here. So find right rotation data and click the Set Offset button to apply this. After that, you need to choose one of the rotation direction setting. This will determine the rotation direction when the robot need to meet the rotation offset. Now, after you click the Apply button, you can get a vision workspace for this vision system. You can make additional vision workspace for this vision system. Let's go back to the programming screen to make a simple pick-and-place movement using Vision command. Add a JMove command to make a start point of this program. And then, let's add Vision command to make a movement with Vision system. This Vision command contains default 2 subcommands in its subtree. If you click the main Vision command icon, you need to select one Vision system in the Vision system list. After you choose a Vision system, you can see a new drop-down box contains Vision workspace for that Vision system. In this way, you can use multiple Vision workspace in the same automation program. After you select the Vision system and its workspace, click the Capture command inside the subtree. As you can see on the Command Property tab, this is a kind of J-type movement to move your robot to the standby point for taking a picture. This position is standby position where you've already made for this specific workspace in the previous step. Type the speed and acceleration value for this movement and modify the options for receiving vision data. Number of requests determines the maximum number of attempts to get a OK signal and find vision data from the vision system. Robot will repeat pulling the trigger until he get OK signal and position information. Waiting time determines the delay time between the triggers. You can monitor the status of your vision system and whether robot gets OK signal or not by using a simple variable. After setting is done, let's click the next command in the vision subtree. This command is a kind of linear movement, and this will move your robot just above the target object which is detected from vision system. As you can see in the command property tab, this command contains only speed and Z position value, not X and Y position. Robot already knows the X and Y position data from the vision system. So, click the set point button and move your TCP to save only Z position data in the base coordinate. If you add a movement command just after the previous movement command, this will make a relative movement based on the previous one. You can also add set command to activate your end effector to pick up an object. Let's add some simple commands and click apply to save this program. I'm really sorry, but I cannot show you how this vision command works in this Roadie simulator because there is no actual vision system connected to robot. But you can find out how to use this vision command with your own robot and vision system if you follow this video. Now, let's go to the next step of this chapter. I will let you know how to use pattern command. This command is very powerful and useful command when you want to make a complicated pick and place motion with HCR. Let's add two movement commands for start point and wait point just before the pattern motion. And then, click the pattern icon to add a new pattern command. After you add a new pattern command, you can see 5 kinds of preset pattern types in the Detail tab. Stack, unstack, line, square and box. They are preset pattern types which many operators usually want to make. You can choose one of them to make your customized pattern motions. In this command, you just need to make a few required positions and intervals even if you want to make thousands of points. This is a kind of linear movement, so you can choose frame and also customize coordinate when you make a pattern command. In this way, you can easily copy and paste complicated pattern command by clicking few icons instead of teaching for hours. In this training course, let's make an unstack type pattern first. Let me guess that 8 simple objects are piled up and you need to pick each object up one by one and move them to the new stacking point. Let's choose unstack type and click number 1 icon and click the set point button to move your TCP to the first pickup position. After that, click number 2 icon and click set point button to move your TCP to the last pickup position. And as I said, you need to type 8 for count field because you have 8 objects. After you type the count, Roadie will automatically calculate interval and you can monitor that before you save the pattern. Now let's click apply button to save and play this simple program. As you can see in the simulation screen, TCP moves to the each pattern point step by step. Let's stop this program and click the pattern point icon inside the subtree. This pattern point icons contains position data of all pattern points. You can just need to adjust the speed and acceleration value for this movement. This is a kind of linear movement and you don't need to click set point button to save a position data. If you click Move button, TCP will move to the first pattern point as you can see on the screen. Now, let's try to make relative movement for each pattern point. Click pattern point icon and click Move icon to add a new movement command. In this case, you can see a movement icon with strange image. According to this movement command, TCP will make relative movement from each pattern point and this movement is also a kind of linear movement. Let's make some relative movement like me and play this program. Now, as you can see on the screen, TCP goes to each pattern point with 2 relative movement from each pattern point. You can also add a set command inside the pattern subtree to control your end effector. Okay, let's go to the next step. We will make a box type pattern movement in this step to stack 8 objects. Before you make a new pattern point, let's make waypoints to move your TCP to above the stacking point. And then, click Pattern Command button again and choose Box Type. In this box type pattern, you need to make 4 waypoints and 4 interval counts to complete this command setting. Let's save 4 waypoints step by step and make your own box pattern like me. In this case, you have to type 2 for each count field because you have totally 8 objects to stack here. You can see total count of your pattern points in the Detail command tab after you type counts. After you complete to make a box pattern, let's add relative movements for this pattern command. Now, let's click play button to see how these two pattern commands works. You can see the movement of your TCP on the screen, and it goes to each pattern point step by step. In many cases, I recommend you to use loop or if commands and related variables to control pattern commands independently. Now let's go to the next step. In this step, I will let you know about advanced functions for this pattern command. Click your pattern command icon and click Advanced tab to see detail options. First of all, if you activate the checkbox name Start at this position, you can assign the start point from your pattern points. This function is very useful when the automation system is stopped by any interruption and you need to resume the system. Without this function, you need to clear and arrange the stacking and unstacking points because your robot will always try to go to the first pattern point. In this case, you have 8 pattern points for unstack patterns, so you can type a number from 0 to 7. 0 means the first pattern point and 7 means the last pattern point. If you type 2 in this field, robot will pick your object at the third pattern point when the program starts. Let's press check location button to move your TCP to actual pattern point and confirm whether that point is right or wrong before you click the play button. Now, let's use this function for box pattern command and choose pattern point where you want to start at. To use this function for box type pattern, you need to type numbers for each edge. After you set these functions and click the play button, you can see the motion of your robot in the 3D simulation screen. In accordance with you typed 0,1,0 for this function, TCP goes to the third pattern point of this box pattern. Now, let's use another advanced function for pattern command. Click the pattern command you made and click Advanced tab. Below the Start at this position function, you can see a drop-down menu and select a variable to monitor the status of pattern command. Before we use this function, let's make new variables for each pattern command. Now, you are ready to use this function with variables. Assign variables for each pattern command and click play button to monitor the status of pattern command. In Monitoring tab, you can check the sequential changes of your variables. These variables indicates where your TCP will go when the pattern command runs in the next loop. Please observe variables closely when this program is running. You shall be able to interpret and transform the number to a pattern position for using other option. Now, stop this program and activate new option name. Use the position to move as the setting for the variable. This option will allow you to move your TCP in accordance with the variable for every repetition of program. In this way, you can change the destination of your TCP when the program is running. Let's activate this option for your pattern commands. There are two ways to change the value of variables when program is running. Please add a set command just before each pattern command and choose the type of assignment. After you save the program and click the play button, you can assign variables for each pattern command manually. If assigned variable is not proper, you will see a pop-up message like this. When assigned variable is proper, you can see that TCP moves as intended. Also, you can assign the number through the Modbus communication function. This is an advantage which differentiates collaborative robot and HCR from industrial robots. Now, let's go to the final step of this chapter. Let's add a path command and click the command icon. After you click the red button on the screen, robot will go into free drive mode and you can move your robot by your hand. And Rody will record every motion of your robot before you click OK button on the screen. I'm sorry, but this simulator will not work this command properly, so I recommend you to use real robot to practice. If the path is properly recorded, you can move your TCP to the start point or the end point of your path by pressing the S or E button. And also, you can play the path command independently and adjust the speed of the recorded motion. There are import and export button to copy and paste this path motion for other robot. Please be aware that you cannot see the path of your TCP in 3D simulation screen. This may cause accidental collision or other unexpected motions. If you want to trim duplicate motion which make your robot seems to be stopped just after the recording starts, please activate this checkbox and click apply button. This is useful function to trim your path, but sometimes, Rody trims too much so he may lose the original start point. The offset between trim start point and the point just before this path command is very small, but you may not play the program because of this offset. In that case, please press S button to move your TCP to the trimmed start point and click the movement command just before the path command. And then, click Set button and click Apply button without any other actions. This sequence overwrites with current position data on this command and no more offset will be left. Please remember this tip when you are faced with problem from over trimmed start point. Congratulations! You've completed all basic training courses. Now, you are ready to make your own automation system with HCR and will become a professional engineer and also operator of HCR. Thank you for your concentration and I hope to see you next course. Hanwha Precision Machinery will be glad to see your feedback about this course and video itself. Please feel free to contact me by email or survey as below links.